Hello everyone, today's topic is on area. Unit 5, Day 3, our objective is I will be able to determine the area of 2D shapes. Now there are 6 kind of categories of shapes that we're going to be talking about finding the area for, and those include triangle, rectangle/parallelograms, rhombus, trapezoids, regular polygons, and circles. Okay, so when we find the area of a triangle, we're going to do area equals 1/2 base times height, where the base and your height are perpendicular. Okay, for a rectangle or for a parallelogram, and I just want to go over real quick, a parallelogram is when you have 2 pairs of parallel sides. So you can see the top and the bottom are parallel, and then these sides are also parallel. Okay, so whether you have a rectangle, or you have a parallelogram, you will use the same equation, which is just base times height. And again, your base and your height must be perpendicular. Okay, when we talk about the rhombus, we're going to use an equation 1/2 d1 times d2, where d1 and d2 are your diagonals. So our diagonal 1 is this one going all the way down, and the diagonal 2 is the one going across. You're going to take those values and multiply them, and 1/2. A trapezoid is defined by having only one pair of parallel sides. So as opposed to a parallelogram where you have those 2 pairs of parallel sides, trapezoids only have one. And whatever those parallel sides are your bases, base 1 and base 2. And your height is again parallel or perpendicular to your base. Okay, this is a very common trend. Your base and your height are always perpendicular. We'll use the area formula 1/2 times the quantity b1 plus b2 times the height. For a regular polygon, now a regular polygon is defined by figures that have multiple sides where all of the sides are the same. So we can have a regular polygon right here that is like a triangle where all the sides are the same, or a square where all the sides are the same, or a pentagon where all of the sides are the same, or an octagon, 1, 2, 3, 4, 5, 6, 7, 8, close enough, where all of the sides are the same. In all of these instances, we can use a regular polygon equation, 1/2 times the apothem times the perimeter. Okay, so this is useful when you have, again, regular, all of the sides and angles are congruent polygons. Now the A represents a unique measure called the apothem. The apothem starts from the center of the figure and meets one of the sides at a 90-degree angle, right? So the apothem for a square would be right here. For this pentagon would be right here. For this octagon would be right here. It meets each of those sides at a 90-degree angle. And our P represents the perimeter. So we can find the perimeter by adding up all of the individual side lengths and then multiplying it by 1/2 and the apothem. And in order to find the area of a circle, we use the equation pi r squared, where r represents the radius. The radius is from the center of the circle to the outer edge of the circle. Okay, we're going to go through a number of examples of how to use these equations. So the first one, teacher example number 1, we're given this figure below. And what we can see is we have one pair of parallel sides, which makes this figure a trapezoid. So we're going to use our area equation, 1/2 b1 plus b2 times the height. Now we know that our base 1 and base 2 coincide with our parallel sides. So we know that B1 and B2 have to be 6 and 8. And we know that the height must be perpendicular to our base. Therefore, our height must be 4. So if we put that through the calculator, you'll get the area to equal 28 units squared. Go ahead and try student example number 1 on your own. For teacher example number 2, we're asked to find the area of this figure below. And we can see that all of these side lengths are congruent, which allows us to use our area equals 1/2 AP equation for regular polygons, where A represents the apothem and P represents the perimeter. Right here, this 12.4 feet tells us our apothem, and our perimeter we can calculate because we know one side length is 18, and we know there are 5 sides, 1, 2, 3, 4, 5. And that 18 times 5 is 90. So our perimeter is 90, so we're going to multiply 1/2 times 12.4 times 90, which gives us a total area of 558 feet squared. So go ahead and try student example number 2 on your own. Now our last teacher example asks us to find the area of this figure. And we all know this figure here is a circle, so the area equation is going to be pi r squared. Since we're told this entire length going all the way across the circle is 36, that represents our diameter. But since we need the radius, we need to cut the 36 in half, which gives us a radius of 18. Now we're going to plug it into our area equation, pi times 18 quantity squared, and plug that through the calculator. We get an area of 1017.9 inches squared. Go ahead and try student example number 3 on your own. Okay. And go ahead and write a reflection.